And for pre-calc, and especially for those forms, standard, alternate, ultimate. So especially for the one of those couple problems in the packet right there in the back, page 4, 5, and 6. Alternate A, secant or cosecant. So let's say that is cotangent. So A cotangent of B times the quantity of x minus h plus k. So you might be wondering, so how do we set up that amplitude period? So the way to come up with that, so cotangent, there's no amplitude involved, so A is just a scale factor. Scale factor as well, but that's the one we use to find the period. So period for cotangent is always pi over b. And then k, which is for the vertical translation. So like this. So y equals 4 cotangent of theta over 3 plus 4 pi over 3 minus 2. So you may notice that this one is almost getting close to the ultimate form, but the thing is that we need to factor out b, so b is 1, which is the greatest common factor. So we took out 1/3, so we got theta plus 4 pi minus 2. So for A, we have 4, which is the scale factor. So that means the curve is going to be considered vertically stretched. And then B, 1/3. So for which is 3 pi. And then H, it's negative 4, shifted 4 pi units to the left. And then K, negative 2. One of the most important factors here, we need to do the one cycle test. So for the one cycle test, as you may notice that cotangents, the parent graph, it goes from 0 to pi. So from 0 to pi, it's a reflected cubic curve. Over 3 plus 4 pi over 3. We want to solve for theta. So subtract 4 pi over 3. So and then pi minus 4 pi over 3. So we pi over 3 minus 4 pi over 3, which is negative pi over 3. Now be careful with this. This one is being negative. And then theta over 3. That's what we have for the remaining element. And then last but not least, we want to multiply it by 3. So that means theta, it goes from negative. Okay, so for the one cycle graph, okay, so here's the y-axis. And then negative pi. So you may notice that would be the other vertical asymptote. So we want to find out half of the distance right between negative 4 pi and negative pi. So the way to do it, we can use the midpoint formula, which is x1 plus x2 over 2. So negative 4 pi plus negative pi divided by 2. So we got negative 5 pi over 2. And also half of the distance between negative 5 pi over 2 and negative pi. So we do have negative 7 pi over 4. Then over here, so 13 pi over 4. Changing curve. So normally this one would be, but it thinks that for the scale factor, so we need to make it vertically stretched. So over here is going to become 4. 1, 2, 3, 4. And then down And then over here in the middle, the midpoint, it's always 0. So now basically just connect the curve. Again, this one is just the parent graph because we're not doing the vertical translation yet. So that, and then with the vertical translation, so we need to move all point down by 2 units. So this one's going to be 2 units down. So 4 minus 2, so 2 units down. And then negative 4 minus 2, 2 more units down. With one shot, otherwise you have to just erase that and then change that a little bit. And also this part right here is supposed to be skinny as well. So here's the final graph. Okay, so now let's do another alternative. Let's do the one with secant or cosecant. So again, it's pretty much the same kind of structure for secant and cosecant with the ultimate form, but the thing is that for A, so we need to start with the initial amplitude, and also A would be considered the scale factor as well. So which will give one of the examples from practice piping. So for equals 1/2 secant of theta over 2 plus 2 pi over 3 minus 1. We don't like in math, fractions, graphing, and also word problems, decimals, and also formula that you need to apply. So let's start out with A. So A, you may notice that's 1/2. So we're using that as the initial amplitude. For B, we do have 1/2. So for the equation here, we want to rewrite it. So y equals 1/2 secant of 1/2. Well, it's going to be use it. It's 2 pi over 3. So it's 4 pi over 3, and then minus 1. So amplitude, initial amplitude, the scale factor, the value B, so we can find a period, which is 2 pi over 1/2. And also moving to the left. And then so for the one cycle test of secant, so this one it goes all the way to 2 pi. Now, got to be careful of that for cosecant. It's also from 0 to 2 pi, but 0 is not included because the vertical asymptote. But for secant, this one you both consider in the quantity. So theta over 2 plus 2 pi over 3. Both sides, so 2 pi minus 2 pi over 3 over 3 minus 2 pi, which is 4 pi over 3. We got theta over 2 remain in the middle. So in order to have, we multiply everything by 2. So we got negative 4 pi over 3 less than or equal to theta to 8 pi over 3. So this one shows the initial position and the final positions. And now let's start it with the and then all the way over here, 8 pi. That's the midpoint right between. So negative 4 pi over 3 should be a left and left. divided by 2. Okay, right here. And then between negative 4 pi over 3 and 2 pi over 3. So we do have 2 pi over 6.